right, today we're here with a beautiful 1995 Mercedes W210 model. And this is the E230, and it is the Elegance. Beautiful, beautiful car. So my dad had one of these when we were young, and boy, did we have fun in that vehicle. Brings back lovely memories. The problem with this car is the infrared remote does not open the doors. So the backstory is this car was working fine. It went to a body shop for detailing. Now I'm at a garage which received this for the troubleshoot, but it went to a body shop, a different body shop, and they did the detailing. So I asked them, what exactly did they do? So they say they did the interior upholstery, the leather, the dash, the trim, carpets, and the ceiling fabric. And they did a very good job. But they said that after the work, they noticed that the key no longer opens the door. Now, this door is a pain to open. Mercedes, in their wisdom, decided not to put the key lock on the driver's door. They put it on the passenger's door. So to open the door without the fob, you have to open the passenger's door, kneel on the seat, stretch your hand all the way to the center dash, and you press the central locking here. Now the central locking does work, so it closes and it opens the doors, all of them nicely. So the central locking system is working, but it just does not work with the infrared remote. So the owner wants it working because it was working before. Now I asked them, did you do anything? Did you try and troubleshoot the car? And they swore that they did not do anything. Now I do not trust mechanics in Kenya. Body shops, automotive shops, they'll all lie. When they tell you they didn't do something, I can guarantee you they did it. Now, I may be jumping the gun here. I've not looked at this car yet, but you may wonder, why don't you give them the benefit of the doubt? No, I will give them the benefit of the doubt when I realize during my diagnosis that they indeed did not tamper with the system. But I don't trust these guys. I think they did something. Now, when it comes to security issues, when you're dealing with keys and alarms and stuff, always ask your client to provide for you all the keys in their possession. So this client has 2 keys, and here they are, both of them. This one with the Mercedes logo is the one that is used on the daily, and this other one is the one that is hung at home for emergencies. Okay, so let's try. The one that is used daily is this one. Let's try the fob. Nothing happens. Okay, let's take the backup key. And nothing happens with this one either. So we don't have any activity on both keys. Now, I don't know how this system works. So the best place to start is let's go to WIS. Let's find out how this system works. And then we're going to go to the wiring diagram. And then we're going to pull the wiring diagram for this system. And then we're going to troubleshoot from there. We're in WIS, the thing that I hate to use. Let's go to table of contents, and we're going to go to functions, passenger cars, model, and our model is 210. And then we're going to go to central locking, now this says function description of central locking, but as you can see here, it's as of 1/6/97, model 210 as of 1/3/97. So that's not us. Let's back out of here and let's look for table of contents, function description, infrared remote, central locking with drive authorization system, stage X. Then here it says 210 accept this as of 696 up to that, the US version. That's not us either. Let's back out of here. Let's go to stage 2A here. Then it says here 210.2 accept 210.281 up to 28.297 accept code 491 US version. So that's us. All right. So let's look at some functions here. Function description, infrared remote control for central locking with drive authorization system stage 2A. Get in there. All right, so let's look at model 210. That's model 170, model 202, model 210. So in model 210, we have this one. You've got N101, which is the multifunction control module. And then you've got N54.1, which is the infrared DAS control module. Then you've got the key lock and the key. And then you've got a few points here where you've got the left, right turn signal lamps. And then you've got the engine control module and the engine. And then A267 is the RCL receiver. So the remote receiver is in the mirror assembly, interior rear view mirror. The key is going to transmit to the mirror. Okay. So this is one of them. Let's go back out here. So that is drive authorization system, the DAS stage 2A function. Now let's look for the infrared drive authorization system control, DAS, location and purpose. Model 210 up to 28.297, so that's us again. But we have another one here, FBS X. Let's look at this one. Now in this one, let's go to model 210. This is this one. Model 210 with HFM SFI engine control module. That's us. So we have an N54 or an N54.1. Okay. So N54 is the RCL control module. N54.1 is the IR DAS control module. So there are two types of systems depending on which module you have. If you have the N54.1, you have the DAS system. If you have N54, you don't have the DAS system, you only have the IR control receiver, which is just for the remote key. And then again, you have the mirror N34, that is your engine control module. And then you've got your door receiver here. And then you've got your key. So now that we know this, let's go to the car and see which system we have. All right, so according to WIS, we've got two systems. There's the DAS2, which has got the N54/1 module, and that's behind the instrument cluster. And then we have the infrared only system, which has got the N54 module, which is under the passenger's footwell. So let me ask the guys first to pull the footwell board over there, and we're going to see if we have the N54 module. If we don't have the N54 module, then they will pull the cluster and we'll release the N54/1 module from there. And here we go. First try. We have the N54 module. So this system in this car is the infrared key only system. It is not the DAS2 system. And by the way, DAS stands for Drive Authorization System for Mercedes. So first thing I've noticed here, what do we have here? Huh? What was that they said again? Nobody did anything? Liar, liar. Somebody was here and they did something. These are fresh, and obviously something was attempted here. I don't know what these wires are. So let's go to the wiring diagram and pull up the wiring diagram for the infrared remote only system. And then we're going to see what these wires do. And then we're going to take it from there. All right, before we go to the wiring diagram, let's see the functions of these components. Let's go back out here and we're going to now go into infrared remote control for central locking, RCL function. Get in there. And model 210.2 except 210.281 up to 28.297 except code 491. So this is us. Illustrated on 210 model sedan. So we have our key. Our key has got a transmitter, and then the receiver is the mirror here. It says here, when the IR remote control key is actuated, an infrared signal is transmitted. If this infrared signal is recognized as valid by the DAS infrared control module, the latter actuates the pneumatic system equipment, PSC, locking or unlocking the vehicle via the central locking. So here we've got the function of unlocking vehicle. So let's look quickly into this. When a valid infrared remote signal is received, the vehicle is unlocked if it was previously in the locked state. The confirmation unlocked is accomplished via the green confirmation lamp in the receiver module as well as via the turn signal system. That's good to know. So the LED on the mirror will blink green when it is unlocked. If the infrared remote control is actuated continuously on models this, and we are included here, the emergency opening function of the side windows is started when the convenience feature is used for closing immediately previously. The green confirmation lamp comes on as long as the remote control is actuated. All right. Then let's go to the locking function. When a valid infrared remote control signal is received, the vehicle is locked if it was previously in the unlocked state. The confirmation locked is accomplished via the red confirmation lamp in the receiver module as well as via the turn signal system. When the infrared remote control is actuated continuously on models this and 210 is included, which is us, the convenience feature is actuated for closing the side windows. The red confirmation lamp comes on as long as the remote control is actuated. And then here we have the USA function. We don't need that. Special functions. If a key is inserted in the ignition starter switch, S21, the remote control does not function. That's another thing which is good to learn. When the ignition is on, or for approximately 2 seconds after switching off the ignition. So the remote is disabled if the ignition is on. Very good to know. All right, let's go back out here. And lastly, disabling remote control keys function. I think we've already read that. To prevent the vehicle from being operated with an IR remote control key which has been stolen or lost, it is necessary to inhibit the remote control with the handheld tester. Okay, so this describes you flashing out keys that have been lost using the remote control hand tester, which is basically the scanner. The number 1 through 8 of the remote control key to be inhibited must be determined. For this purpose, the following information can be read out of the DAS infrared control module. Now, this gives us more information. We have keys 1 through 8. So this module is capable of storing 8 independent keys. All right, now that we know this, let's now go to the wiring diagram for that module. Okay, we're in Starfinder. Let's go to model 210 and web ETM with Starfinder. Central locking, and we're going to go to infrared remote central locking, model 210 up to 53196. That's us. And here's our module N54, and it is powered up by the fuse and relay box, and we've got a terminal 30. Let me just zoom in here a bit. So we've got a permanent power supply here on terminal 30, pin 12, and that is on the red-blue wire. And then we've got an ignition power supply on pin 9, that's on the black and red wire, and that's terminal 15. And then we have a ground on pin 1, that's terminal 31, which is a ground. Then we have a lock and unlock signal here. This one takes a signal from the front left door for the lock and unlock. Then we have E54, which is the RCL function indicator. So these are the LEDs. And then we've got the rear view mirror here, which has got two LEDs. Oh, so this is not the LEDs on the mirror. I think these are the LEDs on the door, if I'm not wrong. I think one of the doors has got two LEDs on them. So the mirror has got also two LEDs, and here they are. So there's a red one here, and there is a green one here. And we have them commanded on pin 5 for the red LED and pin 6 for the green LED. Then we have a 5-volt supply that comes out of the module, and it supplies the mirror assembly. And then we've got ground to the mirror assembly, and then you've got another line here which is a signal, and another one here which is a signal ground. So the receiver is in the mirror here, and it's going to transmit the signal through this wire here, the green and violet wire, to pin 7, and then it is supplied a ground. Then we have a lock and unlock signal that comes from there and goes to N10-1, and this is the combination control module. Okay, and then we have a CAN high and CAN low output on a separate connector, and that goes here. Let's see where it goes. So this is our profile here up to 596. From N54 we have our CAN. When we come here and we are up to 596, so we are either here or here. Now U8 is valid for ASR. We don't have ASR in this car. And U3 is valid for ETS. We do not have ETS, so we don't have this. So we are only coming here. There's a connector that splits. One goes to N34, that is the HFM SFI module, engine control computer. And then the other one is the diagnostic module, which is under the hood. Okay, very simple circuit. So what I want to do is first verify whether I have my terminal 30, which is my permanent battery power, and then my terminal 15, which is ignition key power, and then my terminal 31, which is ground. Then after I've verified that these are okay, I'm going to see whether we have a lock and unlock signal from the doors. Then we're going to test the LED lines and see whether they're working, because when I press the key I'm not seeing any LED activity. Then we're going to verify that we have a 5-volt supply to the mirror assembly and our ground. After we've verified that, then we're going to come here to the signal and see if when we press the key we have a signal output. And then we're going to test whether our CAN high and CAN low are good. Okay, on with the testing. Okay, we're ready for our power and ground test. I have my test kit here, and I have my test light. My test light is hooked to battery negative, and we're going to test for power first. So first, let me get a probe. And we're going to use this one here. Then we're going to come here and I'm going to release my connector. Now the first thing I've noticed here is this connector is broken. See that? And there's supposed to be a release mechanism here that swivels, that is attached to this, and it is not there. So somebody has been here and definitely has been playing around. This is my lock. Let me just pull it back and release that. Then that is the actual connector. Now be very careful. After you have removed your top connector, you no longer have the forced orientation that is mandated by this. You can put this either way. If you put this the wrong way around, you're going to damage your module. Okay, now the first thing I want to test is for power. Terminal 30, and that is on that first on pin 12, and there we have terminal 30. Okay, so our power supply is good. Now let's go to terminal 15. Terminal 15 is pin 9. And that is this one over here. And terminal 15, remember, is ignition key on. Let me put on the ignition. So there my ignition is on, and we have our terminal 15 working. All right, now we're going to test our ground. First, I'm going to move my test light to battery positive under the hood. All right, test light has been moved to battery positive under the hood, and our ground was pin 1, which is the first one here. And now let's test that. And as you can see, we have a nice hot test light. So our 2 power feeds and our ground is good. Now while I'm here, let me test for the signal ground. Remember, we had a signal ground for the mirror, and that signal ground is on pin 2, and that is over here. And again, we have a good signal ground output to the mirror assembly. Okay, the next thing I want to test is the LED red and green lines that are being commanded by this box. I've noticed that I have not seen any LED activity since I have had this car. When I turn it on, when I press the key, there's no activity on the LED circuit. So let me test the LED circuit. So the LED red circuit is pin 5, and that is here. That's LED red circuit, and I'm still connected to battery positive. Now when I touch here, I should be able to pulse my LED on and off. So let me just check that, and I am doing that. Let me focus you on the LED up here on the mirror. So watch that red LED. And as you can see, I can pulse that red LED with my test light. That tells me that this circuit from here to the mirror is good. Let's test our green LED. That's the next wire here, pin 6. And again, when I touch here, I'll pulse that LED, which it is working. So let me show you again. So that's the mirror there. Okay, so our green LED is fine. All right, the last test we're going to do here can only be done with the scope. So we're going to hook up the scope on 4 channels, and we're going to test as follows. Channel 1, we're going to test the lock and lock signal that comes from the module to the doors, or from the doors to the module. Then there's another lock and lock signal that comes from the module to the N10-1 module, which is the combination control module. So that's on channel 1. Channel 2, we're going to test the infrared signal that comes from the mirror assembly to this module. Remember, if I press the fob and nothing comes here, this will not respond and do anything. And then our 3rd channel, we're going to test the CAN high, and our 4th channel, we're going to test the CAN low. But before we do that, I may have jumped the gun here, but I actually want to test my keys. Do I have an infrared signal coming from my keys? Now, I see people buying expensive equipment just to test the infrared signal. It's a black box, which when you press the infrared button, and if you get an infrared signal, you get a blink from the black box. Guys, you do not need that. Your phone, believe it or not, has the ability to see infrared. So let me switch off this torch over here. And we're going to focus on the key here. Now it needs to be a bit dark. Let me try and close these doors. So I'm going to focus this key on the camera, and I'm going to press my key fob. If we get an infrared signal, we should be able to see it, because the phone camera is sensitive to infrared and you can see it. And there you go. See that? So this key is transmitting an infrared signal. So this key is good. Let's get the other key. Oh, by the way, when I say good, I mean it has got good infrared output. I don't know about the information that's in the key. Let's get the other key. Right, that's the second key. So remember, the key we tested was there. This is the second key. And again, focus on the camera. And this key does not have an infrared signal. You see that? Nothing is happening. So which key is this? This is the key that was at home. Now, one thing I know about backup keys, batteries die on backup keys. So let me just put good batteries in here, and then we're going to try again. Okay, I got some batteries from the office. They're not new, but they work. I've tested them. So this key now has got replacement batteries inside. Now let's test the infrared. And there's our infrared signal. So both these keys have an infrared signal. Okay. Now let's hook up the scope here on the remaining channels, and we'll proceed with our testing. Now, before we test the other lines, we need to test our 5-volt signal that is going to our mirror receiver assembly. Okay. Picoscope is set up and it is running. So let's come down here, and we are going to test for that 5 volts. It is on pin 11. So let's come here. That's pin 11. And as you can see, we have a very good 5-volt signal going from here to the mirror assembly. So that mirror assembly should work. All hooked up. Channel 1, we've got our infrared signal from the mirror receiver. Channel 2, over there on the red, we have the lock and lock signal from this box to the N31 module. And by the way, this box does not have the wiring for the door switches, which is an option in different cars. So on this car, we only have the lock and unlock command being sent to the instrument control module. Then channel 3 and 4 on the green and yellow, we've got the CAN high and CAN low. Scope is running. Let's first observe the scope, and what we can see is we have got no short on our CAN because both those lines are at around 1.5 volts. So we are ready to receive and transmit signals on those lines. There is no short there. So what I want to do is to take my key, and I'm going to depress the remote while pointing that infrared signal at the mirror. And as you can see, we do have a signal coming from that receiver. So what does that tell me? That tells me that the transmitter in my key is good, the receiver in the mirror is good, and the line between the mirror and this box is also good. So let me try that again. There we go. And let's take the second key. All right, I've taken the second key. And we're going to try that again with the second key. And again, we have the same transmission. So this doesn't look good for our box here. It looks like our box is dead because we have inputs but no outputs from this box. There's no CAN signal, and there's no lock and unlock command coming from that red channel. I'm also interested in that CAN signal. I want to see whether we're going to get any CAN communication. So let me try and start the engine and see if we're going to get any CAN signals, at least when we start the engine. We need to see whether we have CAN activity. Now, as you saw there at the beginning, we did have some CAN activity when I put the key on initially. So my CAN high and CAN low lines are good. So we are done. We have a bad box. Now, I will need a new box, but this is a security item and it has got vehicle specific data. You cannot take a module from a different car and just swap it in here. It will not work and you will get frustrated. In fact, let me go on the EPC and I want to show you something interesting when we're going to look up this part with the keys, and we're going to see what Mercedes say, and then I will explain how it is that you can change this module. All right, here in our EPC, this is found in a weird place. It's found under the group front doors, and then you come here to paragraph 3. And this is our unit. These are our keys. Now look at this. When you pick this, the infrared key, or when you pick the control module, actually, that's what I want to show you. So let me focus on the control module. You see the control unit, you have two types. So you have FBS 2 and we have FBS 2A. And ours is 2A. Look at this. When ordering, please do not fail to fill out the form completely and to put it on file. Order for spare keys locking units. In case of criminal investigations, you should at any time be able to give documentary evidence. Drive authorization system 2A, FBS 2A, theft relevant part. And then there are these that are given here. So this part has got vehicle specific data to this car, and it is only for this car. In this module, there is an EEPROM, which is an electronic erasable programmable read-only memory. This EEPROM contains data specific for this vehicle. In order for us to fix this vehicle, we need to get a donor module, and then we need to transfer the EEPROM data from this module to our donor module so that it works on this car, and then we sync our keys, and then our keys will work. But there is another problem that we will encounter. Let me discuss that problem, and then we shall proceed with the repairs. This is our module. I've opened it, and I want to show you what these items are. So let me blow up this picture, put it on the screen, and I'm going to identify the components of interest here. And then I'm going to tell you the complication that we will potentially come across and how you can avoid them. And then we can proceed. So there's this, and there's also the key. I've opened one of the keys. I will also describe what you're seeing here in the key. So let's start with this module. This module has got a microprocessor here. That's this one. And then this here is a 14-stage ripple binary counter. Don't mind what that is right now. Basically, what it does is it handles pulse data within this module. And then we've got this chip right here. This one is a CAN controller interface. It's the one that controls the CAN communication in and out of this module. And then up here, we have what looks like an EEPROM, but this is not an EEPROM. This one is a multifunction voltage regulator. It takes voltage input of 12 volts and outputs different voltages, 5 volts, 1.5 volts, 2.3 volts, that are used for the processors in this system. So you can see there's no EEPROM visible here. What that means is that the EEPROM information is inside our microprocessor. Now that creates a complication. Number one, these Motorola processors have got internal thermal protection, which means if you heat this with a heat gun and your heat goes too high, the thermal circuit inside here will open and it will erase everything in this chip. It's a security feature. If you do not desolder this correctly, you are going to damage the chip and you're going to have no data to work with. Number two, there are security bits inside here that even if you do not destroy the chip as you're desoldering it, you are likely to not be able to read the information here because it has got a security bit. And be careful with this security bit inside over here. If this chip reads that you are attempting to read it from a device foreign to this board, it will trigger an EEPROM erase. And when you attempt to read the EEPROM in here, you'll get all Fs, which is zeros. You're not going to get any data from here, and it's going to be permanently destroyed. In order for you not to destroy this data, only read this with a reader that is specifically tailored for hacking that security bit. I know of only two. That is VVDI Prog and Orange 5 reader, of which I do not have either of the two. So I need to find somebody who has it. And then the third issue you're going to have is soldering this thing back onto the board without shorting your pins out. Those are the three challenges we have. Now, why do we need to remove this from here? We need to remove this from here and put it into our donor board because our vehicle specific data is here. But we also need to read that EEPROM so that we verify that our keys are correct. Let me now address the key. For the key, the data is stored in this EEPROM over here. Okay, so again, I'm going to blow up this figure and put it on the screen. And you'll see that this EEPROM is the 93C46 EEPROM. This one is a simple EEPROM to read. In fact, I'm going to read it myself using a simple CH31 programmer. and we are going to read this information and then verify that our key is valid. Because if we do all this and we don't have a valid key in here, we still are going to have an issue with this key. It's not going to work. All right, we're in the office and I have removed my microcontroller. I used low melt solder on this. Now, low melt solder will not go past 120 degrees centigrade before it melts. Then it remains molten and I'm just able to lift it off. Then I use solder braids to clean out this. Not that I really need to, this is an old one, and that is my microprocessor. So step 1 complete, removing the microprocessor under very low heat conditions. Now step 2, I have already found somebody who has an Orange 5 programmer, and they're going to remove the EEPROM data from this chip for me. All right, so let me just send that over to be done, and then we're going to go on. Now, before we continue, I want to know whether we're going to have valid key data from this key. I really have a feeling that somebody attempted to tamper with this key. So let me pull out my CH341 programmer and let me set that up, and then I'm going to read the key information that is here. We're also going to read the key information for the key that was at home, which is this one, and then we're going to compare them. Depending on what we find, it will guide us on where to go next. Now, you may wonder, do I really mean CH341? Yes, this cheap programmer is what I'm going to use to both read and write, if necessary, our keys. I have started getting into programming because I have been messed up royally by programmers in our country. I've noticed that people here just follow blanket instructions that you're given. Connect this here, connect that there, and then press this key, load this file, etc. They actually don't understand what they're doing. So when something goes wrong, which has happened to me 3 times and has bricked 2 cars in the process, they do not know what to do after that. So I've approached it from the standpoint of what is an EEPROM, why do you program, what do you need to do, and that is why I got this little unit to start playing around with as I am learning how to do this stuff. It has been a necessary thing for me to do. I'd vowed never to get into programming, but here we are. So you're going to get to learn how I do some programming myself in this video. So let me set this up and we'll pull our data from our key. All right, my chip is connected. The clip is there, ready to be read. And there's my programmer. Now let's go to the computer and fire up Neo Programmer, and then we're going to read that key. All right, let's fire up Neo Programmer. And we're going to select our chip 93C 46. Now it says here 8 or 16-bit. This chip is a 16-bit, and I'm going to show you that in a minute. So let's read, and always verify. So that's a good read. So let's save this, and we're going to save it as key 1. All right, that's our key 1. Now let me set up for key 2, and then we're going to do the same. All right, that's our second key. That chip is slippery, so I am propping it up with my pick. Let's read it. Okay, let's read the second key. Right, that's the read. Let's verify it. Very good. And let's save it. And we're going to save this as key 2. Alright, the chip is back from the programmer and he has sent me the bin file. Let's keep our fingers crossed that he read that chip correctly. And how will we know? If we open our bin file and it is all F's, then he messed up and he has bricked this chip. If we find valid data, then he did a good job and we're good to go. He didn't call me, so I'm assuming he did a good job. So let's go here. That is our bin file. Let's right click with it and we're going to edit it in Notepad++. Now I'm going to use this simply because it displays very well on the screen. Let's view it in hex. And the programmer did a good job. This is a valid EEPROM file from that chip. So that also tells me that our microprocessor has not been damaged. Very good. So we've bypassed the scariest part. But remember, we still need to solder it back to the donor board. And by the way, the donor board is here. So, nothing much to see here. Now, what I want to do is, let's close this. And let's go to our 2 keys that we read. These are the 2. I'm going to open them in Notepad. What I want to do is to move this to other view. And then we're going to view this in hex and view this in hex. Now, I will tell you one thing. This key ID is 5F. This key ID is 5E. This was the key that was at home. And this was the key that was active in the car and the key that consequently went to the body shop. And I can tell you right now, this is an invalid key. This is a partially deleted key. You see all these F's? We're not supposed to have this many F's here. The first part of the key is valid, but something has happened here. Compare with this one. See these U's here, these U's. This is a normal looking key, but this one is invalid. So somebody attempted to reprogram this key. Those lying buggers, they said that they did not touch the key, nor did they try to do anything. This shows that they were lying. They had tried to program this key and it failed. So what are we going to do? Let's generate a set of keys from our EEPROM file that we got, and then we are going to write new sets of keys in these 2 keys. So let me boot to my Mercedes profile and then we're going to continue. All right, here we are in our Mercedes profile. We're going to go to DAS2 Calc. Now, this is a software, a very old one, that is used to calculate keys for this type of module, which is what we have, also for this type of module. Okay, so we have the EmoBox HC05. Let's open the bin file that was sent to us, and then we are going to select all keys. So we're going to generate all keys. Master key is key 1, and then all these are subsidiary keys. So let's make the keys. It says here wrong version, so let's try version 2. Very nice. That's created for us the key set. Okay, let's close this out and close that out. And now let's boot out of this and let's go back to our regular profile and then look at those key sets. Now we're going to go to our key sets. Now I want us to open all of them, and I'm going to show you something interesting. These are all our keys. So let's quickly view all of them in hex, and I'll explain to you what's happening here. Then we're going to arrange them from master key, which is key 1, all the way to key 8. All right, so now they're arranged. First thing I want you to look at is your master key. Look at address 0. Look at the byte here. See, that's 58. That's a master key. So when you see two numbers, that's a master key. And then 59 is your first key, backup key that comes from factory. So these two are the two keys that the car is supposed to come with, master and backup. And then these are the subsidiary keys, backup keys that you can create. Now I want you to see what happens to address 0 and address 20. They're the same, 5A, 5A, but I want you to see what happens as you go up in key ID. So that's key 3, key 4, see it's 5B, key 5, 5C, key 6, 5D, key 7, 5E, and key 8, 5F. So this tells me that the key he had at home was 5F. That is a subsidiary key. It's not the secondary key that came from factory. So both his keys have been reprogrammed. They're not his original keys. I don't know where his original keys are. Now, watch this. His was 5F. We're going to compare his 5F ID key with our key here. But let's look at 5E. You see, this is a valid key. Let us open the other key that we read, which was invalid. So that was key 1. This was an invalid key, and this was a key that went to the Bodyshop. So let's view in, we move to other view. And then we're going to look at the proper subsidiary key 5F. Look at this. This is how a valid 5F key is supposed to look like. And if we compare, that whole data here, his has been erased. See all those Fs? His key was erased. So somebody tampered with key 1 that went to the Bodyshop, that we know now. But I'm also interested to know, is the key that was at home valid? The key that was at home was 5E. So let's close this. And then let's close that. We know that's an invalid key. And let us go to our keys and open key 2. Remember, this was a key that was at home. View in hex, move this to other view. Then we're going to compare this 5E with this 5E. And they're not the same, guys. Plugins, compare in hex. So there are a few differences here. You can see here, this 2 bytes, C1, this is E4. This is OE60. This is 2A5F. This is 13OA, and this is 0204. So this key, I don't know. You know, this is a calculation from my software. So is this a valid key or not? My thinking is that this is a valid key. Maybe it was generated by a different software. Here's what we're going to do. We want to restore this thing to factory. So we're going to come here to our master key, key 1, and our factory backup key, key 2, and we're going to program this into his keys. And then we're going to solder the microchip that has come into the donor board, and then we're going to come back to the car and sync these 2 keys and see if this will work. All right, I've loaded the master key inside. Let's just read it, verify. Now let's open our key sets, and we're going to put key 1. Let's program it. Very good. And let's verify. Excellent. So this key is complete. Let's do the backup key. All right, the second key is loaded. That clip gave me a hard time. I need to get a new clip. Let's read. Let's verify. That's good. Now let's load key 2. And let's write to it. And verify. And we are done. First and second key loaded. Let's put the keys together and then go back to the car and test. Okay, our replacement board is in, and we have changed our MCU and soldered it to this board. So we're ready to do that testing. Let's get the keys and begin the synchronization process. Okay, ready to synchronize. We start with our master key. So we're going to point it to the mirror, hit twice, and then within 30 seconds, put it in the ignition and turn the key on. And look at that. There was a green light that flashed. And now, oh wow, nice. So this works now. Excellent. Let's see if the car will start. Oh, now look, we have a blinky there. So this car may not start. I think we need to wait for that to finish what it's doing. Okay, so we're done. Let's put the key off. And we're going to put the key back on. And we're still doing that. So I don't know what that is, but let's try and start. Yeah, so the car will crank but not start. Okay, so that's our first key. Now let's take our second key. We hit it twice. Then ignition on. And we are doing that. Now let's hit it twice again. Actually, now this one is synced. Okay, good. Close and open. All right, now our system is working as it should. Now let's take our first key. Close and open. Beautiful, that's working. Let's take our second key and close and open. Very nice. Now let me try and see why we have a crank no start. Oh, now we're not flashing. Oh, interesting. So is that all it needed? I think it needs to see the master key whenever you sync a new key. All right, now let's try the master key. Put it in the ignition. On. Look what we have. So let's see. Okay, so the master key will not start it. Let's take the secondary key, put it in the ignition, and now again we have this. So let me figure out what's happening with the alarm system, because that's the alarm that's armed and it stops the car from starting, and then we'll proceed. Okay, there's nothing wrong with the system. What I've found is if you open and then close the door and then try and start, that is construed as a suspicious activity. It's unusual. You're supposed to close the car and then the car should not be started. And then when you come back to the car, you're supposed to open it and then drive off. So this car is actually working the way it should. So right now the car is locked. So let me unlock it. This is the master key. Let me unlock it. So one hit, it's unlocked. And then you open the door and you get in and then you close the door. And now you put the key in the ignition. Watch the mirror. Key on. See that? And now there is no suspicious activity according to the computer, and now you can start the car. So that is normal. Okay? And then when you reach home, take the key out, you open the door, you close the door, and you arm the system. And that is how it's supposed to function. So that is the master key. All right, let's wait 5 minutes and then we're going to do that with the secondary key. All right, a couple of minutes have passed. Now we have our secondary key. Remember, it's locked. So let's unlock. Very good. And then we come and put the key on. And again, all okay there. And we should start. Very nice. Then you can drive off, reach your destination, put off, get out and close, and then you arm your system. Beautiful. Oh, and in case you're wondering, those were the LEDs I was talking about. That's locked and unlocked. So somebody tried to punch the key through here thinking there's a key lock in there. Let's test the alarm system. I'm going to use both keys to do that. So let's assume you've armed. So that's locked and you've gone away. Now let's test the anti-tamper system of the car. I'm not going to use my key to open the door. It's still locked, but I'm going to open the door from inside and let's hear the alarm. Very good. So we're flashing, alarm is on. And now we should take the key, close the door. Let's hit the key once and it recognizes that this is a key that is valid and it shuts off the alarm. That is good. That is the master key. Now let's do the same test with the secondary key. Our secondary key is here. Lock. Nice. Wait for a few minutes. Good. Put the key aside and let's open the door. Very nice. Close the door. Still have our secondary key and let's see if it will recognize it. Beautiful. So both keys are registered, fully valid by the system. All right, let's do our final test. Let's now see what kind of signals we have at the module. Normal signals when you arm and you disarm and you start the car. I'm interested to see what the CAN does, what the lock and unlock does, and what the infrared signal is with both keys. Okay, so let me set up for that. All right, our last test here, connected just like we had before. Channel 1 is our infrared signal from the transmitter. Channel 2 is the lock and unlock signal. Channel 3 and 4 are CAN high and CAN low. Now let's look what the signals do on a normal system with both keys. Okay, let's do the final checks on these signals. Let's start with the master key. I will first lock. All right, let's pause the scope and let's save this as master key lock. So we see that the key transmits, and that is the signal that the key will transmit. And then the module pulses one down here, and I think this is a LIN bus. And when that pulsing is done, the doors open. So that is the close command. Let's run the scope again. And now let's do the open command and then the ignition key on. I want to see what happens on the can. Okay, so here is open, and then the ignition on. Good. Let's pause. And this one will authorize startup, just in case you are wondering. So let's save this as master key unlock, and key on. All right. So we see here that we have, again, the key signal, but this time we have a different data packet sent on the lock and unlock. So this is a LIN bus. So this is the open command for the central lock. Beautiful. And then this CAN activity here is the valid authorization for startup. Now let's move to the secondary key. Start the scope. Again, we are going to lock with the secondary key. That is lock. Let's pause this. And then we're going to save it. This time it's secondary. And again, we see a nice key signal here. Now, this is not the same as the other key signal, I can bet you that. And I will do a frequency comparison between the lock and unlock for the master and the secondary key, and you will see. Now, let's start the scope again. Let's do the secondary key unlock and then key on. So unlock and then key on. And you can see we have a valid authorization there. Let's pause it. Let's save as. Secondary key, unlock, and key on. And again, we see the LIN signal for the central lock. You have the key signal there, and our CAN for authorization is this one here. Looks exactly like the first one. All right. Now, one more, and then we'll do the comparison before we close out. All right, let's do an invalid activity that will trigger no crank. That is when you are unlocked, like right now we are unlocked, and then we're going to lock the car and then turn the ignition on. That is an invalid activity. It's a suspicious activity. So let's lock. So we're locked. And now let's put the key on. Look at that can. That can activity is wild. And we have that flashing alternate, and we are now going to start. Very nice to see. And now let's pause that and let's look at the can, and we have this alternate packets here. No, 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 no. Over and over again. So that's wonderful to see. So security system is working as it should. That is an invalid activity, and this car is good to go. And now lastly, I'm just going to show you on screen here a quick comparison between the master key and secondary key lock and the master key and secondary key unlock. You're going to see that the frequencies are different, but since the frequencies are registered in the module, they are going to be valid. All right, we are done. 1995 Mercedes 210. Wonderful diagnosis and repair. And now our system is working with the IR key. And what have we learned? Number one, do not trust when mechanics or shops tell you, oh, we didn't touch anything. These guys not only touched, but tampered with the key. And then second thing, do your research, and when you do your research and use factory information, you will never go wrong. Another one for the books, and we'll see you next time.